Hi, Julian here from PopcornFX. In this video, we're going to see how to work around a common glitch often found when using ribbons. So here, if I switch to wireframe on this effect and slow down the simulation speed and zoom in the head of one of those ribbons, you can see this glitch here. And this is due to the fact that the leading particles that spawn the ribbons will spawn a child particle once they've traveled a certain distance from the previous child. So this means that we're missing the head segment of the ribbon, which causes the texture to be cut. And this makes some very visible artifacts. For example, this was a simple arrow texture, but if I switch to this texture tile here, it makes it really horrible. So the usual way to work around this would have been to fade the the head of the ribbon, so that the first segment is transparent and starts being non-transparent only after a certain distance, so you don't see that cut. But I'm going to show you another way to do this, which works by decimating the particles. So you'll notice that here, if I go into the leading particles, I select the trail node. If I increase like crazy the spawn interval, well, actually if I decrease like crazy the spawn interval, like let's say 0.05 instead of 0.2, this kind of hides the issue. Let me hide the leading billboard. You can still see some of those glitches, but as I make this value smaller, like 0.01, here there are no more glitches. However, if I switch to wireframe, you can now see that these ribbons are horribly dense. I'm at like 600 to 700 particles, whereas before I was only at around 30, 40 maybe, yeah. So this is a dramatic increase in the number of particles, and we don't want that. So one way we can solve this is to actually increase the trail density, but in the child particles kill some of those dense particles once enough time has elapsed, so that the rest of the trail is actually low density and only the head is high density. So it will all become clear once it works and you see the wireframe. So one way I can do that is access the parent dot emitted count. So this is basically the particle ID. So this value is incremented by the parent particle for each child particle it spawns. So the first child particle will be ID 0, the second will be ID 1, the third will be ID 2, etc. And here I can get this ID. So this is effectively the particle ID. So if I take this value and I use a mod operator, and if I mod with, let's say, 8, so this is the modulus with 8, so every 8 particles, this will be 0. So this will output a value between 0 and 7, and yeah, every 8th particle will be 0. So here, if I do an equal test to check if it is 0, then wire this into an if node. Here I can change the actual life duration of that particle. So here, when it's 1 every 8 particles, I will set the life to be the actual life I want here, so 3. And otherwise I will set a much shorter life, meaning 7 out of 8 particles will die much quicker. So let's say 0.2. Now if I wire this into life, now you can see that in most of my trails the short-lived particles have already died, so I have a lower density trail, but only in the head, in the first 0.2 seconds, I have the full density trail. So you actually want to adjust this based on the size of those segments. So here, for instance, 0.2 is way too large, because I only need this highly dense region to span the size of a single segment to avoid those artifacts. So I could probably reduce this to, say, at least 0.1. And even 0.1 is a bit too much, but I'll keep 0.1 for the time being. So now, if I remove the wireframe, you will see a visual mess up at the head. This is because the texture U coordinate we use to stretch the texture over the entire ribbon is using the self-life ratio. Here I'm using the curve over time node with the cursor set to life ratio, but I'll just remove all that and use self-life ratio directly, just so it's simpler. And the self-life ratio of the particles that live a short time will still be 0,1, and because they don't have the same lifespan as the longer ones, the longer lived ones, this will mess up entirely the U coordinate here. So what I need to do is to use the actual age of the particle in seconds instead of the normalized age, and this will ensure that every particle, no matter how long they live, will have coherent U coordinates, as it will be based on the actual seconds and not the normalized age. So if I use self.age and wire this directly in the texture U, you can see now that I do not have any more artifacts, but the ribbon is much shorter. Well, that's kind of expected, because self.age will go from 0 to 3, because my max life here is 3 seconds. The length of my trail is 3 seconds, so I will actually need to divide this by the length of my trail in seconds, so here 3, to get the proper effect. And now when I switch to wireframe, I have the high density head that hides the cutting artifacts and the lower density body. So I will actually want to pull that 3 out in a separate node, because these are should be the same values. When I change this one to make the trail longer, I should also change that one, and I'll name that trail length in seconds. So whenever you want to change the length of the trail, you only change that node. Like if you want to compute it based on a payload sent by the parent particle or whatever, just change that and it will ensure that everything works correctly. So if there are any other places in your trail particle where you are using the self.life ratio, be aware that using this technique will require you to replace all your self.life ratio or curve sampling cursors or whatever by this computation here. This is your new self.life ratio that you should wire in instead of using the built-in self-life ratio node. And you can see that I'm back to a much more reasonable particle count. It's still way higher than before, but that's also because I have a higher density trail, but it has nothing comparable with using the real full density trails here. And you can actually make those less dense, just increase the value that you mod by. Using powers of 2 will make it slightly more efficient at runtime, but it's not really that important in the end. I'll keep it to power of 2 here, so I'll just increase it to 16. And well, yeah, this just made my trail higher density, but I can use, I don't know, something like 30, which is not a power of 2, and it will work properly as well. Now regarding how to tweak this, You don't actually need this to be as high. You can have a pretty small value here. I can bring it down to 0.2 or something, and it will still properly hide the glitch. The important thing is that you find a value in your trail, a density, a base density here, that's high enough to hide the cutting artifact you have for your specific texture. Once you find this value with your full density trail, you can just go in here and change those two values, the modulus value for the final density you wish, and the lifetime of the particles of the high density particles. So you lower this until it's until you only have a few of them on the head, and it should work properly. So regarding cutting artifacts, we now solved the head cut, but there are two other cuts remaining. However, these are pretty trivial to solve. It's the cut at the start here and the cut at the end when the parent particle dies. And this is usually done by simply fading the color. So I will create a curve node, wire it into a curve sample node, and here as the cursor I will use the parent.life_ratio. I will wire that into color and make it something like this. So it starts at 0 with full alpha and ends at 0 and fades in, then fades out. And you can see here that I now have no more cuts. It starts with a clean fade and ends with a clean fade too. Make sure parent.life_ratio is at spawn though. If you set it at evolve, it won't work. So yep, that's it for this video. I hope this trick will be useful to you, and see you next time.